All right, so our question for this problem is this. Did you get it?
Yeah.
All right. And then for part A, what we're going to do first is we're going to find acceleration of both the blocks. We're going to make two triangles out of, and we're going to have the weight force as a significant component here. It's going to be our hypotenuse. Yeah, the weight force is going to be our hypotenuse, mg. We know that because newtons, mg. Just is. And then we're going to have, this is our 30 degree, and this is our 60 degree. We're going to have to put the 30 degree and the 60 degree each below their box. So 30 degrees below the box, 60 degrees is below the box. And then after that, what we're going to do is we're going to use our SOHCAHTOA to figure out the the component of acceleration.
A force.
Wait, hold on. 60, 30. Yeah. All right, yeah. We're going to find this. So, because we're going to find acceleration, so we want to find this, and we want to find this. For this one, we want to find this, because acceleration is going that way.
Mm-hmm.
And so for this one, we do sine 60 equals opposite over hypotenuse equals 16.97. And then we do the same thing for this one. Sine 30 equals opposite over hypotenuse equals 9.8. And then after that, we just take these two forces and we subtract them. So 16.97 minus 9.8 equals 7.17, which equals ma. Because this is force. This is the force of the force in this direction. That's what it is. So you just find your F, and F equals ma. And we take that, and our mass is 4, because 2 plus 2. We're finding it for both of the blocks. So F equals ma. Divide by 4, acceleration you get equal to 1.7, 6 something. Where is it?
It's about 1.8, class.
It's the acceleration is 1.8. For part 2 of the problem, what we're going to do is we're going to, we're going to have to know this formula right here. It is F, force of friction, equals coefficient of friction times the normal force of friction. Because we want to find the force of friction. They just gave us the coefficient of friction. So for the normal force, we find the normal force by, yet again, doing another triangle. So what we did is,
What's the normal force? Can you see it, class?
well, yeah, this is the normal force going in this direction. I know that.
Yeah. So what don't you get?
How do we find it again? Oh, yeah, okay. We did cosine of 30 equals adjacent over hypotenuse. Duh. Because we're finding this. So cosine of 30 equals adjacent over hypotenuse, which equals x, your normal force, which is 1.697, is here. And we do the same thing on this side. So we get...
Correction, it equals 16.97. And then the force, the coefficient of friction is 0.1, so it equals 1.697.
Yes. Because look, this is the normal force. We want to multiply the normal force by the coefficient of friction. Adam is right, and the coefficient of friction is 1.1. So
it's 0.1.
That's 0.1. The coefficient of friction is 0.1 times the normal force, 16.97. Then we do the same thing for this sign. So it's cosine of 60 equals x over x over.
I don't know.
X over I do.
You swear on an internet video?
Hold on, wait. Equals x over. Hold on. What is it? Stop! Wait, we can't stop now. Oh, wow. Can't believe I didn't get this. 9.8 times 2. mg over your hypotenuse.
Yeah.
It's not.
Yeah.
So okay, yeah, over your hypotenuse. Because we have this as our.
Okay, class. Either way,
You-
okay, the normal force, which is this force,
Oh, here it is, Adam. Look, this
Okay.
is a better explanation. mg.
this,
Then we're gonna find our normal force. We're finding this. This is 60. 60 times 60 times cosine of 60 times 9.8 times 2 gives you the normal force. Normal force, UFN, we multiply that 0.1, we get 0.98. All right, now we take these forces of friction and we add them together to get the total force of friction. The total force of friction is going to equal 2.677. We subtract that from 7.17. 7.17. You might recognize that number. It came from right here. It's the force in the downwards direction without friction. But if we want it with friction, we subtract. So 7.17 minus 2.67, it gives us 5 something.
4.9 actually.
It actually gives us 4.9. 4.9 divided by 4, because 4.9 is our force, and F equals ma. So m, which is 4, divided by 4.9 equals 1.1. And 1.1 is your acceleration for both of the blocks.
Yay! Good job, Lindsay.
We got it. Now we won't forget.